Okay, we repeat again for the type 1 and type 2 error. So for type 1 error, so the key point is type 1 will be reject H node. Okay, and type 2 will be we accept H node. Right. So these two are type 1 and type 2 error. And so today we were going to use these two principles to do the calculation, right? So we now we proceed to question 8. Okay, for question 8, the study of large sample of books by a particular author shows that the number of words per sentence can be modeled by a normal distributions with the mean 21.2 and standard deviation of 7.3. A researcher claims to have discovered a previously unknown book by the author. The mean length of 90 sentences chosen at random in this book is found to be 19.4 words. Okay, part 1. Assuming a population standard deviation of sentence length in these books is also 7.3. Test at 5% level of significance whether the mean sentence length is the same as author. State your note and alternative hypothesis. Okay, so before we start, normally we will state the hypothesis first. Okay, for this question, H naught will be mean equal to 21.2. And alternative, the question say test whether the mean length is the same or not. Okay, so same or not. Right, this is a hypothesis. So then you need to form your parameter. Okay, so this is your parameter. So once you have this parameter, then you can start to calculate the Z value, right? So the mean that you get from the sample is 19.4, the sample mean from the random sample. Okay, so now we can start to calculate the Z. So Z will be equal to 19.4 minus 21.2 over 7.3 square root of 90. Okay, so by calculating this, you should get Z equal to 2.339. Okay, and this question is talking about a 5% significant level for two tail tests, so it's side 2.5. If you look into the table, you should get Z equal to negative, from the table is get 1.96, so this is negative, you will compare to the negative part, right? So this is smaller than negative 1.96. So if you have this, you can do a conclusion. So reject H naught in favor of H1. Right. So in this situation, once you have this general statement, you can put a final statement according to the context. Okay, so question is the same, whether the mean length is the same as the author. So you can say at 5% significant level, Okay, that the mean number of words in the sentence is not same as the author's. Okay, you can say at 5% significant level that the mean number of words in the sentence is not the same as the author's. Okay, so this is for part 1. For part 2, state in your words relating to the context of the text what is the mean by a type 1 error, and state the probability of type 1 error in this part 1. Okay, uh, so part 2, type 2 error means what? Sorry, type 1 error means what? Type 1 error means you reject hash not. Okay, so this is a general statement. So question is asking you what is the statement that you need to put according to the context. So you reject hash note mean you will say that the mean length is not same as the author's sentence length, right? So you can change this one to according to context. So when you say that it is not same is not the same as the author's length, sentence length, you can say sentence length, but you can say when in fact it is the same as the author's sentence length, right? So as simple as that, you say the length is not same, but actually it's the same. Okay, so this is the type 1 error. Okay, this is of part 2, and another part they say state the probability of type 1 error in this test. Okay, so the probability of type 1 error will be the probability of you reject H note, right? Okay, so for this case, so what is the percentage that you're going to reject H note? Okay, according to the significant level. So what is the percentage in the area that you are going to reject H note? So for this case, it's very simple. Question asking probability will be 0.05. Okay, so because you test at 5% significant level, so means 5% you will reject the H note. Okay, so this is the things 0.05. Okay, so this is for part 2. Okay, now we move to question 9. Okay, for question 9, over a long period of time, it's found that the time spent cash withdrawal points follow a normal distribution with a mean 2.1 minutes, standard deviation 0.9. A new system is tried out to speed up the procedure. The not hypothesis is that the mean time spent in the sum under the new system as previously is decided to reject the not hypothesis and accept the new system is quicker if the mean withdrawal time from a random sample of 20 cash withdrawal is less than 1.7 minutes. Okay, assume that for a new system the standard deviation is 0.9 minutes and the time spent follow a normal distribution. Okay, so type 1, question 1. Question asks you to calculate the probability of type 1 error. Okay, so this question did not mention about the significant level, so you can't directly put the significant level percentage or the probability inside here. So you need to calculate, because the question mentioned that uh, when you will reject the hash note, right, is less than 1.7 minutes. Alright, so anyway, before you start to calculate the type 1 error, you need to form your hypothesis first. Okay, so we form the hypothesis. Okay, so once you have the hypothesis, form your parameter. Okay, your parameter. So now you can try to calculate the probability of type 1 error. The probability of type 1 error is the probability that when you reject the hash note, right, reject hash note. So when you will reject hash note, when p smaller than 1.7. Okay, so same things. Once you have this, you can start to calculate p. This one common to z, standardize. Okay, so by doing this way, you can calculate the z value and the probability. So once you continue, you should get p z smaller than 1.988 and is equal to 1 minus p z smaller than 1.98. Okay, so you should get 0.0234. Okay, so this is the probability of type 1 error. Okay, question 2. If the mean withdrawal time under the new system is actually 1.5 minutes, calculate the probability of type 2 error. Okay, so now we calculate. So the probability of type 2 error okay will be equal to the probability of you accept hash not lie. Right, as simple as that. So just now we say that px the x smaller than 1.7, we will reject hash note. So if we want to accept hash note, we must be have px larger equal to 1.7, the opposite side. Okay, so once you have this, you can standardize and try to calculate the probability. So this is equal to p z larger than 1.7 minus 1.5. Alright, the mean change to 1.5 already. 1.5 this one. Okay, and over 0.9 square root of 20. Okay, so you should get p z larger than 0.994. Okay, so by further calculation, this is equal to 1 minus p z smaller than 1.994, and you should get 0.1601. Okay, so simplify 0.160. So this is the probability of type 2 error. Type 2 error. Okay, so this is for question 9. Okay. Okay, so now we move to the next part. Actually, this is the extension of this. The next part will be a little bit the extension from the discrete test. So, don't make it clear. This chapter will be extend from the discrete test. So, in your syllabus, the discrete test that going to use will be binomial and Poisson. So, if you have these two specific cases, right, check first. Is it possible to use a discrete test first or not? Okay, if this is possible, use a discrete test first. Okay, don't use CLT first, use a discrete test first. Okay, so CLT normally in your syllabus we just apply to the cases that the distribution is unknown. Normally we will not apply to the binomial or Poisson first, right? So unless the question told you to do so, okay, normally if possible we will use discrete test first, okay, then unless the question asks you to do CLT, then you use CLT, okay. But if the distribution did not mention any distributions, okay, unknown, so you may need to apply CLT directly, okay. So this is a different. So now uh if based on the discrete test, next chapter actually is a discrete test. Okay, no issue. We touch about discrete test first. So if based on discrete test, you will need to check back. Okay, you will need to use back the original principle from the Poisson and from the binomial. Okay, let us see how we carry out the approximation first. Okay, we using the Z test when the n is large. Okay, so now we talk about binomial distributions first. Okay, I still remember if we want to convert a binomial case, okay, to a normal distribution approximation. So what should we do? Okay, so if this situation we need to check NP, is it larger than 5, and NQ, is it larger than 5? If this both fulfill, we can use the approximate the discrete data of a binomial distribution to a normal by NP and NPQ, right? So this is a criteria for you to fulfill in order to do approximation to convert a binomial discrete data to a continuous data normal distributions. Okay, so if you go further, we will go for question 10. Okay, question 10, we will see do the how to do the approximation in the hypothesis test, right?